Is there an ABC?
One answer is, oh yeah, sorry, why am I launching this? This is not an ABCD. So the 100% vote for, yeah, forget it. So the question is, why? Because it looks badass was one answer that I heard, which may be the correct answer, but I don't think so. I think there's actually some physics to it. Yeah, Kevin.
The force of friction doesn't depend on the contact area if you have the coefficient of friction, but the coefficient of friction probably depends on the contact area.
Did everyone hear that? Let me repeat. He says the frictional force doesn't depend on the contact area, but the coefficient of which kind of friction here? Static friction may depend on the contact area. What do you think? Coco has a thumb up, but she's falling asleep. What else? Yeah.
You want the tires to survive, so if you spread out the force of friction, it's the same force of friction no matter how big or small.
Do you drive race cars? You're the first person who's nailed it in 3 years. Say it loud and say it proud. You want big tires so your tires don't pop, okay? What is going to happen as Leadfoot steps on the gas?
Leadfoot.
Okay, there's going to be a request made from Leadfoot to the tires. Please give me a whole whopping amount of friction going which way?
Backward.
Oh yeah, because you want the car to go backward. Let me give you a hint. F equals ma. If you want to accelerate forward, the net force better be going forward. Thank you, Ian. All right, so you want a whopping force forward. Okay, that's going to scrape perhaps some rubber off the tires. Imagine you had a skinny little bike tire on that thing, like in the front. Okay. Okay, the tire's gone, boom, okay, end of race. So you want, in this case, a lot of area so that if you scrape off a little bit of the rubber, you don't ruin the frictional force and the tire.
What about a thicker tire?
Yeah.
And also the force on each part of the tire will be less, so it's spread out over a larger area.
Why is that important? So he says the force over each part of the tire will be less, because it's spread out over a greater area, which I agree with. But why is that important? He says because the rubber has a limited shear strength. So, yes, so the amount of force per unit area of the contact between the tire and the asphalt is lower because you're spreading it out over a bigger area. You won't rip the rubber molecules apart as easily. So the tire will last better. Fantastic. That's amazing. Okay. Another example.